Hey, how's everyone doing today? I got my cup of coffee. We're good to go. Had a lot of meetings this morning. Maxim, good to see you here. Maria, good to see you here. Cassandra, good to see you. Victoria, good to see you here. Let me get Mubot awake. Oh, it says he's awake. It says Mubot's awake. Got my coffee. Good to go. How's everyone doing? And what are you doing this morning? What are you learning? What are we practicing? A little music, little coffee. If you're in the chat, feel free to say hi. It was a busy morning. Busy morning. If you have questions, drop them in the chat. We'll start working on some. Could you please go over the investment website question on Chapter 13 quiz? Of course. Cassandra, thank you for being here. Cassandra, I bet you a lot of students. Cassandra, I'm throwing you 500 points. Because asking the questions helps out a ton of students. And I appreciate it. We're going to head over here. Let's take a look. I'm trying to think, when is my... I have a panelist practice at 1:30 today. It is such a busy day. Do you have a busy day? Put what you have in the chat. I had some meetings this morning. Would really love if you could go through the visualization. Ah, yes, the decision trees, right? Let me put that on the... I don't even have a list. I don't even have the notepad open. So yesterday, I restarted the computer. I did a power cycle on the modem and the router. We've rewired everything. I'm running OBS in administrator mode, and we're going to see if we get any disconnects. Zachary wants to talk about the visualization also. So we'll do some visualization after this. So we've got, is it investment website? Stat 201, chapter 13, investment website, and stat 201, visualization, decision trees. Okay. Getting the investment website open. If you have more questions, let me know. Hopefully, we have no streaming issues. We're not supposed to talk about the streaming issues, or else they'll happen randomly. There we go. Investment website. We've almost found it. Can we do it by the end? Philanthropic organization. School referendum. A bank. New restaurant. Marketing research, an investment website. Here we are, and the time is 4:55. Let's go to investment website. Okay. Thanks, Brian. Oh, you're welcome. Anytime, Zach. Thank you for being here, Zach. 100 points. Appreciate it. Definitely check it out later. Okay, an investment website can tell what devices are used on their site. So they're going to tell if you're using like an iPhone, an Android phone. And no joke, you can tell that from the data collected, the metadata collected on site. You can see, was someone using an iPhone? Because it'll tell you usually the browser, and it'll be like iOS, or you can tell the device type, things like that. The site managers wonder whether they should enhance the facilities for trading via smartphones. Probably, very important. New restaurant, definitely. And the proportion of people use it. They draw from a random sample of 448 investors. Suppose that the true proportion of smartphones... You can tell this is an old question. Let me drink a little coffee right here. It's saying that the true proportion of people who have smartphones going to this website is 31%. Not trying to make fun of the question, but we live in 2022, and this question was probably written maybe more than a decade ago. At that point, there was not 31% smartphones. It was, oh, you have an iPhone, and now it's, oh, you don't have an iPhone. Galaxy and other things exist, Pixel. But back in the day, back when I was a kid, not everyone had a smartphone. Frankly, we just had home phones. My mom used to have party lines where they would share telephone service. That's pretty crazy. I can't imagine that. So she's seen some major changes. So here's the information, and let's walk through this. Now, what we first want to do when we get a problem like this, we want to understand what's going on, what it's asking as we read the problem. But then the next step for the problem is going to be to mark the notation. So Cassandra, if it says the true proportion of people using smartphones is 31, you just have to type one letter in the chat. That is what? And it says, suppose the true proportion. So these are key words. Can anyone put that one letter in the chat for what the true proportion is? Now, we'll be covering this tomorrow in very in-depth. This is due on Thursday. So it's a good assignment. We're going to cover it. I would probably work on it that night. It's due Thursday. Test is next week. If we get this down and we know when it says the true proportion is this, we should immediately mark that in notation and say, okay, the true proportion. So Cassandra, what is that? Like, these are keywords when we say, oh, the true proportion is this. immediately mark that in notation. Like that, you say, true proportion. Okay, I should put a letter. So what should we put, Cassandra? Well, we're out of here for 100 points. And a good answer is I don't know. If you don't know, don't worry about it if it's I don't know. But we're going to drink a little coffee right here. See if you're watching at home right now and if you can figure out what the true proportion is in notation, because that's going to help us for equations. While you're thinking that over, I'm going to write some notation down here and see if you can think of, if I say true proportion, what true proportion is in notation. Like, what of these letters is the true proportion? So which of these letters stands for true proportion? Because it'll help us solve the equations. Which of these letters is the true proportion? So if you don't know, make sure to take a note as you're watching this right now. Like, oh, true proportion, that's which one of these? True proportion is P. P is the true proportion. And this means, like, it is a fact that 31% of people have a smartphone. Now, this does not go with the sample size. It's like for all people. If you somehow had knowledge of every person, you would somehow know that 31% of people have a smartphone. We are going to take a sample. And so this is a sample size. And the question is asking theoretically. And I think that's what usually gets to people about this question. It's a theoretical question of asking what would happen if you sampled 448, very odd number to sample. But theoretically, if you were to sample that amount, what would you expect to see in a sample of this size? And we need one more bit of notation, and that's going to be Q right here. Q is the complement of P. So the way to find it, and we'll show it here mathematically, is to do 1 minus P. So when we go here, 1 minus P, we can get the other side of it, 0.69. Oh, well, 1 minus, there we go. Make sure to do it in your head to double check the numbers. P and Q should add up to 1. So Q is 1 minus P. Make sure it adds up to 1, and 31% and 69% add up to 1. P and Q have been found. Now that we have the notation, we can actually go through and talk about what we would expect to see. And the first equation right here is usually what gets people, because it sounds rather redundant. The first equation states that we would expect to see, that's what mu stands for, the expected value, the mean. So we would expect to see in a sample that says sample proportion, P hat is sample proportion, the true proportion. So it's like saying, if I know 80% of students like Taco Bell, I would expect in a sample for 80% of students to like Taco Bell for a sample proportion. Like I talked to 200 students. With my 200 students, I'd expect 80% of them to like Taco Bell. And this is the sample portion I expect to see if the true proportion is this. The next one is the standard deviation, which is the variation, because we're not always going to see 80%, 80%, 80%. There's going to be a spread to it. And that gets down to a very important thing right here. And then when we're talking about these distributions, and let's go ahead and solve the numbers, well, the mean of it is going to be 0.31, and the standard deviation of it, we'll solve it right here. Make sure to plug in the numbers, so I'll write them so people can practice. 0.31 times 0.69 over 448. Make sure to trace your numbers up, the ones that I'm using up there, and my bad handwriting, make sure to be able to read it. So we go right here, and we times that by 31. We're good. We divide by 448. We're good. We square root, and there we go. So 0.021, or 0.022 rounded. And we'll be using this here in a moment. I wouldn't round it till the very end, but we're going to round it so we can write it down. And that is the standard deviation. So we know the mean of the distribution. We know the standard deviation of the distribution. Now I would draw the distribution. These will be normally distributed. Normal curve is your bell-shaped curve with the mean at the center. So this value right here is going to be the center of the curve. And then this is the standard deviations. So we'd go right here, up, 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 3 standard deviations, and down, 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 3 standard deviations. This is just a sketch of what we'd expect to see given the data is normally distributed. So the mean is at the center because we would expect most likely to see, on average, 31% of people having a smartphone visiting our site. And then we're just going to do a little rounded version of this where we go up 0.22 each time. And so this would be 0.332, 0.354, 0.376. And then we go down 0.288, 0.266, I think that sounds right, and 0.244. You can confirm your numbers right here by taking and subtracting from 0.31, and there's that, and then do another minus, there's that, there's that. So those are the exact numbers right there so we can see it. These are the big steps. We haven't even looked at the problem yet, but we're using the techniques from this chapter to find the mean of the curve, the standard deviation of the curve, and then to draw the curve. So although you can draw the curve yourself, I highly suggest going to the David M. Lane applet. And what you'll notice right here is when I go to the David M. Lane applet, once Mubot puts it in the chat right here, it's going to draw the curve for me. So remember, I found the mean of the curve, which was 0.31, and the standard deviation. So this drawing you see on the screen right here, we'll try to make it so we can see both at the same time. This drawing you see on the screen right here, make it a little bit bigger, I could have drawn myself as I did. So please realize that when you're using the applet, it's often best to draw the curve with the applet. I'll put it up here so you can see both of mine. There's their drawing, and look at the numbers on it. I even put in all the decimals, but you can see the exact numbers I wrote down. And so you want to practice writing this out yourself and then also use the applet to solve it. Because we could ask you a test question like, what would the z-score of this be, which it's going to be very easy to see if we have the curve, or how likely would this be, and the curve will help us with that drawing. So we're going to use our drawing right here for a moment, see if we can kind of answer these questions. Let's take a look at what the question says. What would we expect the managers to see for the shape of the curve? Now, if all three conditions are passed, that we randomly select these 448 users, if we have less than 10% of the total population of users, condition 2, and condition 3, we have at least 10 expected successes and at least 10 expected failures. And we would see that right here, because if there's 448 customers, we'd expect 138 to have smartphones, 139 rounded, and then the amount we would expect to not have smartphones is this. That passes what we call the success failure condition. The three conditions, again, for it to be normally distributed are randomly select your customers, less than 10% of your customers are selected, and you have at least 10 successes and at least 10 failures. So write those down. Randomization, less than 10%, and success failure. And make sure to review them. Good conditions to know for the sampling distribution of the sample proportion to be normally distributed. And so it would be unimodal symmetric, which means normal. What would the mean of the distribution be? We already found that right there is 31 because that's the truth. P is the mean of the distribution of the sample proportion. What would the standard deviation be? Oh, that's all it wants. That's all it wants. Oh, darn. I thought it was going to ask some more in-depth questions. I was really excited. Oh, darn. I thought it was going to go into, like, what would be the probability of this? I'm so sad. I need to make the rain better. I'll work on my rain effect here another time. So it could have asked us, what is the probability that 35% of people will use smartphones? If it had asked us the probability that 35% of people use smartphones, which some questions do, we would go right here and we'd put a mark where 35% would be. And then we would graph to the right of it. Now, 35% is going to be close to a z-score of 2. 0, 1, 2, 3. It looks to be a little bit less than a z-score of 2. And with that in mind, we could have a test question that would ask us, what is this probability right here? So that probability we can tell is pretty tiny, and we would know that it is a little bit more than 2.5, but less than 16%. Make sure to review your normal techniques to find out these answers, where we find out 2.5% of the area is above 2 via the 95% empirical rule. Then 95% is contained within positive 2 and minus 2 z-scores. So this always holds true for z-scores right here, kind of limiting what we're seeing on the curve right there. So we can see if we have 95 between these symmetric portions, then we would see right here 2.5 outside on either side. We care more about that highlighted region because from the orange line over is a little bit more than 2.5. You can see we've shaded more than where this line is at. So let's see if this is a tiny bit more than 2.5. We'll go to our applet right here, and we'll actually pretend they had asked us this. So above 35 should be a little bit more than 2.5. I'd guess about 0.032, about 3-4%. And there it is. I guess 0.032, and my guess would have been very accurate. And also, please remember, the goal of this is that we could kind of make a drawing that looks like it. If you look at the actual drawing via the applet right here, here's the drawing from the applet. And then here's my drawing, which looks very similar and helps us estimate the area. And this is where you're going to get the practice right here to be like, okay, how much is this? Can I use the empirical rule to find the answers? And what would I guesstimate? We don't have a bunch of guesstimation on the test, but I would know for certain that this has to be a little bit more than 2.5. So we could give you an answer like 1%, 1.5%, 2%, 3%. And the answer would have to be 3% because it has to be more than 2.5. So that's how we can test you without you using the applet, which is a big question. Like, well, how would I solve this without the applet? We could multiple choice to make it that only one answer is theoretically possible. Well, that's got it. Let's go talk about the visualization. Going back to the main screen. Who all is here? Let's throw out 100 points. Who's all here right now? If you're in the chat, feel free to say hi. Got the music playing good. Mubot's just talking to me. Let me talk to Mubot. Hi, Mubot. Mubot will talk back to you. He's always here for us. Always relaxing, having a good time. Hey. Heading over here for the project. Let's take a look. Some free music from YouTube here so we don't get copyright claimed. Trying to get my headphones perfect. Visualization number something. Number 6, do Friday decision trees. Oh, we're doing 2? Okay. Let's do this. It's time for some visualization on decision trees. So when we do decision trees, make sure to have Jump installed on your computer. If you have questions, please check out the resources I have on installing Jump. You will download this Jump dataset right here and open it inside of Jump and get ready. Here we go. We'll do a little 2 hours later and we're opening it up. And let's take a look. Open it up. If you have problems, please contact us immediately about Jump. Like immediately. Try downloading it now, see if it works. And if you get to right here, you're good. You've got it downloaded. Now, if you look right here, we have a lot of responses to this survey. We've got 1,905 responses. So you can see all the questions asked. We've got original row number. Oh, it says identifier on that. That might be something important. We've got here gender. We've got here age. We've got here whether or not someone was born in Tennessee. You can look at them a little bit easier if you go over here, really. And there we go. Weekly hours, textbook read, all these questions right here. Is vaping safe? We don't use identifiers. I agree with Maria right there. Maria, 100 points. Thank you, Maria, for chiming in right there. We're not going to use identifiers or categorical variables that act like identifiers. So you can actually do yourself a favor right now. Now make a note, like this is a variable we removed. So you probably want to say, I removed the identifier because we don't use identifiers in decision trees. I could get into the mathematics on why, but there's mathematical reasons. We'll leave it at that for now, unless we have a big thing or things that have more than 10. Generally, 10 is like that, like everything is kind of like shades of gray in statistics. It's not like when it hits 10, you're like, you're out. It's like 10 is like, ooh, that's a lot of levels. And so we're going to make sure to mark down this variable you're removing right here, but deleted. Gone. It's gone. It's gone. It's like the pencil. But now other variables, and I might not tell you which ones totally, but you can talk in the chat, maybe some ideas. If you want to see what the distributions look like, you can click this button right here and Jump. And this is going to show you either a histogram or a bar chart. So why on some of these am I seeing a histogram or I'm seeing a bar chart? So why do I see a bar chart or a histogram? Why am I seeing on some of them a bar chart or a histogram? Why am I seeing on some of them a bar chart and on others a histogram? The type of the variable, Maria, another 100 points. Great answers right there. We just showed the variables chart on our screen for a moment. If you check out that screen, because if it's categorical, you will see a bar chart. If it's quantitative, like GPA, you will see a histogram. Now, the only variables, put CRQ in the chat. Great job, Maria, right here. Put CRQ in the chat. The only ones we need to consider for removal are going to be what type of variables. Like this quantitative variable or this category, the only one we should consider for removal should be what? The only variables up for removal should be what type of variables? The only ones up for removal. I'm not trying to say anything, but you know. The only one up for removal should be what? The only ones up for removal should be what? The only ones up for removal should be what? The only ones up for removal should be what? So we remove identifiers, or we remove things with lots of levels, ones with way too many levels. Now, CRQ, the only things that have levels is only a term we use for what kind of variable. If I say like the levels, I'm talking about what? Like, what does it mean for something to have levels? It basically means responses, but not like number responses. It's like groups. So the only one with levels are categorical, right, Maria? So and the notes say this, that we remove identifiers or categorical variables with too many levels. A lot of times people are like, what's a level? It just means a response. Like, I don't know was a level to this question. No was a level. Like, level is a group of responses. Like, it is like level 1 in Mario. I don't know. Video games, you know I love them. So there's 3 levels to this question. This question's A-okay. This question does not have levels because it's quantitative. This question does not have levels here because it's quantitative. This one looks to have a lot of levels. Just saying. So make sure to look through, see if any of them have too many levels. Do remember that you are only considering the categorical questions. I don't know if you can... might be able to like eliminate down further. But you're only looking at the categorical questions here. How did you see those bar charts? This button right here. This little button right here shows you a univariate analysis of each variable. Great question, Maria. Keep asking those questions. That button right there shows you the univariate analysis, and you can quickly scan through. Marketing research. We got the restaurant and marketing. Wait, did we? No, we did investment website. You bet. Definitely Cassandra. You bet. So we need to take a random sample. It says take a random sample of 800 plus the last 2 of your UTID. So we go here to tables, and we will go to, I forgot for a moment, subset. Oh my gosh. Tables, subset, and random sample size, 800 plus the last 2 of my UTID. That's my last 2 today. And here's our random sample. I'd probably save this in case you need to redo some work. And from here, maybe, you know, we need to remove some stuff. Just saying. Anyways, so we need to remove those variables that act like identifiers or are identifiers. Wink, wink. And next, we need to go to Analyze, Predictive Modeling, Partition. This is where we go to make decision trees. Now I'm going to go a different pathway right here because now I don't want to analyze the same variables you're analyzing. Because you will be analyzing either or. We got an either or this time. Using either Q43 or Q08 as the response variable, and the rest of the variables as the predictors, except for the blah, blah, blah. Take 3 splits in your tree. Your screenshot should include the following. Use multiple screenshots. Include your name in the report, the name of the predictors that were excluded. So make sure to write that. And depending on your response variable chosen, list of the characteristics of the students who text the most in the class on average include the number of students and the average number of texts, or the list of the characteristics who are not in Greek life include the number of students and the proportion of the students. So we're basically going to talk about it. And if you look through here, this is how it's graded. Make sure to check out the grading key and do the things in the grading key. If you are ever not graded by the rubric, the grading key right here, you can always say, hey, Brian, it said I lost a point here. I believe I should get those points. I love that we use rubrics because you can look and say, like, here's where I lost my point. Here's what I need to improve upon. And so you can look, do I have the correct output? You should get the point. Did I take my random sample? You should have a point. Did I include my name? You should have the point for that. So pretty clear and easy to see the expectations for you as you go through here, writing up the characteristics and also the variables excluded. So the characteristics is going to be a major thing. I'll write up including the characteristics of students, blah, 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 who expected all those things. And so depending on the variable type. So we don't want to use the variables you're using because we want to do something a little bit different here. So we've got 43 or 08. We can't use those. We're going to take everything right here and do 2 trees. So watch out right here. We're going to do tree 1. Let's say creation of, put a new timestamp, stat tool 1, decision trees, categorical tree. Okay, so we're going to do a categorical tree right here. We're going to predict whether or not somebody has broken a bone. Let's see if someone has broken a bone. And I do want to show you how I did this again. You might have seen it was really quick right there. My favorite way of doing it is the following way. I click inside of here, and I've removed out the variables that act like identifiers or are identifiers. Make sure you've done that step. Now what I do is I click Control or Command A to select every single variable. Boop. Everything's selected. Now, one way you can do it, and this might be the easier way, so I'll show it, is to take everything here and drag it into the X. So now we're just putting every single variable into the X. Probably one of the easier ways for people to follow along. You selected everything, now drop it all into the X. Now that you've dragged everything into the X right here, you need a Y variable. Don't worry about clicking over here on the left again. Take your variable from the X's and drag it into the Y. Now you'll want to do the following though. Remember, we're going to predict if someone's broken a bone. This is my example, not yours. So I'm going to click it and let go. This is where the mistake generally happens, is a lot of people click and drag. No, click and let go. Now that you've clicked and let go, drag it up to the top. If you click and drag, it'll hover over multiple variables. You want to click it, let go, and then drag up once the click has been done. Now we have all the X's, which decision trees take multiple X's, and they predict one Y. Review of our notes right there. So we're going to go ahead and click OK, and we're going to color the points. Before I color my points, I like to do some color coding, though. You can do a little color coding, not required, by clicking on this with a right or a command click on the Mac and go to Set Colors. Setting the colors right here, I'm going to put the red for breaking a bone to the owl color of red. And the no, by clicking on it, I'm going to put it to a nice soothing green today, like a healing green, like, I don't know, Resident Evil. You play Resident Evil, you know what I'm talking about. So let's go right here and hit color the points. We can see the healing green and the owl red there for people with broken a bone. It's going to help me kind of see what's going on right there. And if you're red-green colorblind, or if you'd prefer other colors, definitely use those. Whatever you think works best for your visualization is your call, your consideration. You can see the yes group up here and the no group down here on the bottom. We're going to hit split, split, split. We have now created a tree with 3 splits. Your tree may or may not be symmetric. If your tree is not symmetric, that's where I spilled coffee on my keyboard. If your tree is not symmetric, that is okay. Some trees do turn out the following way, where it's not symmetric. That's okay. Sometimes it's easier to take screenshots if it is symmetric. My tree, luckily today, did turn out symmetric. You can always do a zoom by doing Command-Shift- or Control-Shift- and zoom in or out. This is just decreasing font size, so you could zoom out to take screenshots. You can also change the figure. Try not to make it look too crazy, though, because you want a decent-looking screenshot. Right there. Now, I would probably include all the output. Now, see, that's a good screenshot right there. We got a good screenshot. Nice one-page output on that. And I might include the last little bits, include the leaf report, and I might include the split history, maybe. So let's go over here, and we're going to get both remaining things that we need to understand when we're doing analysis. We would need, definitely, I think this says do include the leaf report. Might make it a little bit bigger. Control-Shift+ or Command-Shift+. That's what I'm hitting. Control-Shift+ or Command-Shift+. Command-Shift- will decrease. And let's go right here and copy the leaf report. If you get a little extra, you can always take it out via the cropping tool. We'll showcase that here. So if you have a little bit extra, click the picture, go to picture format, and we'll zoom in on so we can see it. I want my pictures to be as perfect as possible. Graders wouldn't take off points, but Brian's a perfectionist. How did you zoom out again? It's control. Are you on a Mac or a PC? Mac or PC? Tell me Mac or PC in the chat, and I'll tell you your direct command on how to zoom out. I believe I know it from both Mac and PC. On a PC, it is Command, you're on a Mac, Command, Shift, and then plus, and then a Mac should be, oh wait, that's Mac Control. And so plus will zoom out, minus will zoom in. So you want to hold Command and Shift at the same time, then hit minus or plus. Is that doing it, Maria, right there? To zoom out, you want to hold Command and Shift at the same time. So you hold Command Shift, and then you hit plus, 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 or minus, 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 but hold with your left hand Command and Shift, and then just hit plus or minus. I think you can also maybe go to the view, and is there a zoom on that? It's like a longer way of doing it. Window, is it on window? I can never find. I just know the quick cue. Yes, got it. Nice job, Maria. 100 points. Thank you for asking. And there we go. And I think it helps to write it down right there so people can see it. A lot of times I try to remember, like if I write it down, it's a lot of times easier for someone to see it and to know how to do it. Because I don't know. I was born in the technology. I was born from technology. It's Batman all day today, or Captain America. I don't know. So now that we have our output, I think this is all that's required. Graders should not take off points for this, but we should know what the split history is. The split history is showing me my really sad R squared. R squared is not so good here. It's going out to 10 splits. There we go. R squared not so happy. R squared is doing really poorly right now. And so this is all the output you are required to know for the test. So not bad to kind of take a look at it all and make sure you see what you got here. Now we want to know the people most likely to break a bone. And kind of makes sense right here. The first thing that it split on was economic level. These are people of upper, middle, middle upper, or lower class. So someone most likely to break a bone for me in my data set was somebody who is from upper class, middle upper class, or lower class, and they're older. The older thing kind of makes sense. Like older people have lived longer, they might be more likely to break a bone. But yeah, apparently there's some class association with breaking a bone according to this data set. So the people most likely to break a bone are this group right here. You can also see that they are group 1. Anytime you look at this output, please know that this can be associated with the leaf report. If you do the bottom leaves in order, these are the leaves. The leaves are the bottom terminal portion of your graphic right here. So we have leaf 1, leaf 2, leaf 3, leaf 4. And if you go down here, it would follow the same order. And I always wonder why those percentages are so weird. I don't go by the percentages. I go by the amounts because Jump doesn't know how to find percentages. What if it isn't symmetric? It'll still be leaf 1, leaf 2, leaf 3 in the order it goes. So if it's not symmetric, no worries. Just look for the group that has the most common. You can see right here, this isn't symmetric, and I can't split that one because it's perfect. This one right here would still be leaf 1, leaf 2, leaf 3, leaf 4, and leaf 1 is this, which means it's associated with the first group in the output. There are 13 people in this leaf, and you can see them right there. Try to look at the output and understand what it's showing you when you look at this and it says 0 people here have not broken a bone. This is the answer to have you broken a bone. When it says no and yes right here, that is the answer to the Y variable of interest. Have you broken a bone? No or yes. That's where usually people get confused because this is not an X down here. This is the Y response with the X's of the group. So you can literally look across here. Probably the best way to figure out what the group is, look at the percentages. I do hate that Jump does weird stuff with those percentages. But if you look right here at the yes group, these would be people from upper class, middle upper class, or lower class, and they are greater than or equal to 23 years of age. And I'll zoom in so you can see a little bit better, but I'm specifically talking about this group right here, group 1, as associated right here. And yeah, and I think that's got it. There's 13 people in this group who have broken a bone, and it's everybody. That's 100% of the people in this group have broken a bone. It's only 13. But yeah, is this making sense right here, Maria, on everything? And you can see kind of a mosaic plot of what's going on. So that's how we analyze and interpret it when it's a categorical variable. And the leaves at the bottom are going to show us the splits for each group. This only explains 4.2% of the variation. So interpreting R squared is very important to know for the test. Huge thing, as we like to say in our class, teaching to the test moments. So 4.2% of the variation in whether or not someone has broken a bone is explained by the variables in the tree. You could send it to me. I could take a look, tell you if it looks okay or not. Probably looks okay. Might be pretty small. Might be not that many big variables. Be careful if it looks crazy, because you might get like a really long string of variable names. It might look kind of hard to read. If you have any concerns, just let me know. Email me, and I'll respond back as quickly as I can. Which is usually pretty quick. I feel bad when I take more than a day. So let's talk about the other type of tree. And great job, Maria, right there. It looks like you're doing well on it. It looks like you got it, right? My variable names are just long. Are they long? Yeah, you're probably all right. Probably pretty good. Get that coffee power. Okay, let's do a quantitative tree. So quantitative trees, let me put the timestamp first. 3750 quantitative tree. So you could go the route of a quantitative tree right here. And what I really like about this assignment, the way it's worded this semester, is it lets you know that decision trees can do both a quantitative Y or a categorical Y. So number of texts in class is quantitative, and that means we're going to analyze the mean for each group. So if we do a quantitative tree, we'll look at the mean for each group, because on average, what would we expect for these groups, versus categorical, predicting something like Greek life, where we'd say which group has the people most likely to be in Greek life. We could talk about the group with the highest amount of text in class. Unfortunately, we're not going to do text in class because we don't want to do the exact assignment. Come on, what fun is that to do the exact assignment? Someone's like, no! Too much coffee today. We're going to go here to analyze predictive modeling partition. That's where we go to make our decision tree, and this is going to let us split people into groups based on their Y variable, and we'll be splitting people up for this quantitative tree based on the mean. As in, if people have a higher, and let's pick one, let's do GPA. People have a higher GPA, they'll go into one group, and people have a lower GPA, they'll go into another group. So we'll try to figure out who has the highest GPA. You don't have to. I just like to make my graphics look all pretty. Good question, Maria. Keep those questions coming. 100 points. Keep those questions coming. You don't have to, and I think it doesn't even require the split history, but that just shows you R squared after each split to see if it's going up in a large way. R squared always goes up after each split, but it kind of levels off if you're not getting kind of new or better variables, which kind of indicates we should stop splitting the tree. So we're going to do our trick again to take our variables by clicking Control or Command A, boop, and then we're going to hold right here. We're going to drag it over here, boop, and next we're going to click one variable and let go. And once you've done this, or we're not doing age, I want to do GPA. You'll click the variable you want. Make sure you take the variable in your question that you're using, and then click and drag after letting go and drag it to the Y. If you click and drag, it will just drag across variables. I've done that many times. And then let's go ahead and click OK right here, and you will see the tree looks different. Also, you can see they're colored in. Kind of looks like Christmas. But we don't want Christmas right now. I'm actually going to fix this right now. I'm going to go to rows and go to clear row states. Clear row states will remove the row colors. I do not want row colors. That's row, clear row states. We'll zoom in so you can see it. Clear row states under rows. Boop. And if you're on a Mac, this bar is sometimes hidden at the top. You'll see a little bar you have to hover over and make that bar appear and then clear the row states. So that way, this is what it should look like. There's Brian Stevens right there. Well, in truth, more like this, high school GPA. I was probably closer to that. No joke. So why do people have low high school GPAs? Well, let's find out the answer. First thing we can do is split this right here. And the first split, the most important split, is gender according to this. The 453 females had an average GPA of 3.85, where the 374 males had an average GPA of 3.63. The next split right here is going to be on, are you in the honors program? Is that also going to happen to the males? No. We split further on the females, and that's our 3 splits. Now, we could additional split this tree, and the males did split eventually on honors program, but it actually split females up further. The person with the highest GPA right here, or the people with the highest GPA that we would expect, would be females in the honors program. And a really good way to view this right here is to go to the leaf report. And there are 4 leaves. Remember, the terminal ends, the very end of a tree is where the leaves are at. There's nothing beyond a leaf on a tree. If there's something out further, then that's not a leaf. So right here we have leaf 1, leaf 2, leaf 3, leaf 4. And let's get that leaf report to better understand the information. This one's a lot easier to read because you can see just the mean for each group and then how many people are in each group. And you can see the X characteristics. Do remember that the mean for each group is for the Y variable. So whenever you're seeing what this is right here, this is for the Y. Whether it be something for our previous tree where it says something like yes or no, that's to the Y question, where the X's are over here, or this current tree where we see the quantitative question with the mean of the quantitative variable. So the people with the highest expected GPA, it doesn't mean you will if you have these sort of X variables, explanatory variables for you, but would be females in the honors program. And we did see that it eventually talked about males in the honors program. I do want to see that. We don't have to do 3 splits, but there's males in the honors program versus females in the honors program. So still some difference. So I would say the group with the highest GPA is the 31 individuals who are females in the honors program, which had an average GPA of, and I would just literally copy paste the number. Yeah. And understanding what we have going on right here is we're just trying to explain why do people have certain GPAs. Thank you, Moobot, always talking in the chat. And these variables do a pretty better job than the last one. There's still a lot of variation we don't understand in this. We only explain 11.8% of the variation in people's GPA based on the variables in the tree, or as we might say it more structured for the test, 11.8% of the variation in high school GPA is explained by the variables in the tree. Get some practice doing that, get some practice saying it, so that way when you get to the test and it gives you a tree, Maria, for 500 points, can you explain the R squared right here? You ready? Here we'll take hours work. Can you tell me the meaning of this R squared in context of the problem? Like this is a test question. Boop, 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 boop. Tell me the R squared. Let's give it a second right here. We'll put on a little chill music. I'll drink some coffee. Interpret R squared like it's a test. So if you got to the end of this video, it's time to practice for the test. See if you can do it. If you can tell me what that R squared right there is. Like if it said interpret R squared on the test, you'd be like, psh, I got this. See how quickly you can do it. You're watching, you're practicing. Say it out loud. Say it to your roommates here. Sing. Sing it out loud. Yes, keep going, keep going. You got it. Maria, that's worth the 500 points. Maria, thank you for the practice. That means we're going to practice up for the test. 14.8% of the variation in the weekly hours people work is explained by the variables in the tree. 14.8% of the variation in the weekly hours people work a job is explained by the variables in the tree. Remember, the X is explained, the tree explains why people work weekly hours. So remembering that Y is what we want to understand. The Y is the Y variable of interest. The X's are doing the explaining. 14.8% of the variation in weekly hours work is explained by the variables in the tree. Now, we don't have to list it out, but that's got it. Good practice, Maria. And that means we're going to write down, we're going to practice for the test. We get to that test question, we're like, got this. Let's do a little more Mop Pearson. Here we go. And thank you so much. I love it when the answer is, I don't know. That's such a good answer. Maria, great job right there. I don't know is one of those top tier answers because that means we got something to discuss. It's like we practice, we're working through it. If you get a second, can you go over let's do some activity here. We got 2 more questions. Let me write down everything as we go right here. We have 3 questions actually, but we got 2 more before this. And then I have a meeting exactly at 2:30 your time. Exactly. It is 2:30 for them, right? Or else I'm already learning. I get interesting emails. The people who want to sell stuff to students are very, 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 very interesting in their emails. They're like, hey, Professor Stevens, I want to sell you this new platform for students to do such and such on. And I'm just like, I don't respond usually. Like 99% of the time. Marketing research. Oh, and then was it the poll, the other one? And Lillian, great to see you here. Marketing research. And I think Cassandra wanted the poll one also. Or the school referendum. I want to find it. Could you go over new restaurant? New restaurant. Okay, and then we have activity. Activity 7, question 2. Okay. Okay, marketing research, new restaurant. Marketing research, we found it already. Okay. Marketing research here at 46, 49. Let's do this. It is time for the marketing research question, and this is on the sampling distribution of the sample proportion. So that means we need to kind of understand what the notation is. So let's take down the question and write down the notation. Okay. When we are doing the sampling distribution of the sample proportion, it's important to know what the question is telling us when it says a marketing researching company surveys 138 people. So that is how many people they talk to. This is instantaneously how many people are in their sample. That is their sample size of the people they spoke to. People who would like to switch, their contracts expires is 22%. So that's what they're finding. Okay. I have a theory problem with this question. Ooh. Oh, yes. Theory problem with this. I need to talk to my Pearson about things sometimes. So the formulas we're using, Brian's sad. The mean for the distribution of the sample proportion is equal to P. The standard deviation, which it asks for, of the sample proportion is equal to P times Q over N square root. Now, what this question should say, theoretically, is it should say, pretend that the true proportion is equal to this, because it's acting as though this is P. The question should be better worded, pretend that the true proportion is equal to this. Now, if P is equal to 0.22, Q is the complement, and that is equal to 0.78. P and Q add up to 1. They are complements of each other, so we can go right here and say 1 minus P is Q, and just remember P and Q add up to 1. They are complements. So we're going to take and plug into the formula P times Q over N square root. And that will solve for us, and make sure to do square root of the whole thing. Sometimes I say P times Q over N square root, and people don't do everything. They stop at it. They don't do all square root. P times Q over N square root. And that's got it. That 3 doesn't look like a 3, but what if my numbers do look like what they're supposed to be? There we go. And so let's solve this. P times Q. We'll start with P times Q. P times Q over N square root. And so that's the standard deviation right here. So with the standard deviation, we can just go ahead and plug that into the question. Drop it in right here, 4 decimals. That's a lot of decimals. There we go. Now that we have the first question, the second one seems like it'd be really difficult. It seems like this is going to be a challenging question. But all we do is we think really super hard. I'm not, maybe, is the brain working today? There we go. How did I do that? How did I know it? Well, there's a trick. It says she wants to reduce the standard deviation by half. How large of a sample would she need? So let's look at the mathematics behind this question. It says she wants half her standard deviation. So we know the standard deviation is P times Q over N square root. And what she wants is she wants half of this. So she wants it to be half the value it is. Now, we can't change P and Q. They are what they are. They're locked. So we'll remove some of the highlighting here so it doesn't look like we're highlighting different things. Those are the values they are. It is true that 22% apparently are people who are going to do X, and 78% are the people who are not going to do it. P and Q are like, you either do it or you don't do it. They're complements of each other. What could change in this equation is the amount we sample. So then we have to think, if we multiply by 1/2, what happens to N right here in the equation? And you would think, well, we can just say right here, let's just multiply by 1/2, and then N is 1/2 of what it was. But that's not the way algebra works. If you want to take and put this inside the radical, well, then this has to go in a radical right here. So if we radical that, that's square root 1/2. It's not the same value. What we need to do is we need to find what would square root to 1/2. And what square roots to 1/2, and I'll show you very quickly, is 1/4. If you have 1/4 and square root it, you get 1/2. Because you have to think, wait a minute, what do we have right here? And it might make more sense if I write it this way. If you square root that, which that is 1/4 right there, if you square root that, you get 1/2. So now this is still 1/2, but it's written in a different way. Like when we square root 1/2, it is going to be able to go into this radical right here, and you'll notice what you get is P times Q over N times 4. And that's what I was working in my head. Since I know, because you could then just take out that 1/4 and square root it. It's a little bit of an algebra problem. I think it's an all right one. It's kind of one of those iffy ones, like theory problems that, like, okay, well, wait a minute, you wouldn't just double the sample size. You would need 1/4 of the sample, or 4 times the sample size. And you can see the algebra right here to solve it. So all I did was take 138. The answer is n times 4. 138 times 4, and that's the answer right there. So when you get to this problem right here, if you look at it, like, do understand the theory and how I'm working the algebra problem out here, but theoretically it could be solved that it's just 138 times 4, or whatever the number is. Good question right there. I really like that last one. It took me a while to figure it out, especially the first time I worked it. I was like, how in the world are we going to figure that out? I was like, oh, if we look at the equation, that might help. Good questions. Heading back to the main screen here. Okay, next question. I think we got new restaurant next. We've done a lot of the quiz today. New restaurant question coming right up. $53, $54. Here we go with the new restaurant. Let's do it. So a new restaurant with 136 seats is being planned. Studies show that 56% of customers demand a smoke-free area. Well, good for them. Smoking can't be done in Tennessee anymore in restaurants. Long time ago that happened. How many seats should be in the non-smoking area in order to be very sure that the mean plus 3 standard deviations of having enough seats is there? So important that we find these values right here. It literally wants us to find what is the mean plus 3 standard deviations. So this is the answer to the question right here. This is what it wants us to solve. And let's highlight, it wants the mean plus 3 standard deviations. If we find this, we find the answer. And so we need to find these values right here and think, okay, so what is the mean? What is 3 standard deviations? Well, the equations are going to help us out a ton. Remember that the mean, mu p hat, is equal to p. That's going to be the easy one to solve. The next equation is the standard deviation, which could be written sigma of p hat. The variation is equal to p times q over n square root. Once we find these, we can plug them into the formula up there, and plugging these numbers in and solving will get us the answer. So the big question becomes, what is p? Well, P is the true proportion of people who want non-smoking seats. And that is going to be equal to, so we need P. P is going to be this. So we know what P is. P is equal to 0.56. And then Q is its complement, which means it adds up to 1. You subtract from 1, and we'll show that again here so people can see. But if we take 1 minus 0.56, we get Q. So P and Q are complements of each other. So now we know P. P is this right here. We found P for these equations. Next, we need to find Q. And we did find Q. Q is going to be able to choose a nice color right here. We'll go with a nice green. Q is going to be this right here. And there's Q. And then the sample size is how many people we talked to. So we need one more color. We'll go with orange today. Sample size is this right here. And so it just becomes solving out the problem now to figure this out. And I think this is going to get us the proportion, so we will need one more step. I misspoke, because I think we need one more step after we solve this. But this is mostly what we need. We're going to find out the proportion, and let's take a look at the answer. So make sure to stay till the end of this question to see how to solve it. And so let's take the mean right here. The mean is P. Well, we know the answer to that. The mean is P, so we have right here 0.56. That is the mean of the distribution. The standard deviation is P times Q over n square root. So Good, I'm not plugging it. And it's going to be a little tiny thing. Never forget to square root the whole thing. 0.0. So we'll put it... Can I move the whole thing? Oh, it's not going to work totally. There we go. So that is what the standard deviation is equal to. And with the standard deviation equal to that amount, so many meeting alerts. With the standard deviation equal to that amount, let's go ahead and plug it into the distribution. And I'm going to use the David M. Lane for this one. Really good practice with David M. Lane. It's the quickest way to draw things out. So David M. Lane is going to show us what this distribution looks like, and we're going to look at where 3 standard deviations is at. Here's the David M. Lane applet. Bring it up here on the page. We're going to put in our standard deviation. We could draw this out by hand. We did problems earlier today where we were drawing it out by hand, but we're going to use the applet right here to drop in the number. And then the mean was 56. It is 56. And we can see, and I hate that it does that. It sometimes deletes the last standard deviation, but 0.688. And that's 3 standard deviations up. Do note that you could find this by hand right here by taking your standard deviation and going the mean of the distribution, the center right here. That's where the mean is at. And then plus 1 standard deviation, 2 standard deviations, 3 standard deviations, same value, and it's a little more decimal calculated right here. We should be good either way because there's a little leeway on this question and a final thing to remember. Now, this is the percent or proportion of non-smoking seats we would want. So we would want there to be a proportion, which is kind of a percent, it is, of non-smoking seats of 68.76%. Now, we have 136 seats at our restaurant, so we need to multiply this to say what amount of seats should we have to be non-smoking. And we would want there to be 93.52. Now, no matter what this number is, you round up. Round up. I'm going to pretend I got a different number here for a second. 93.1. That's not the number that I got, but I'm going to put this in bold, put this in red, and put this. Round up no matter what. So what is the answer to my question if I found 93.1? Who can tell me in the chat? I'm saying round up no matter what. I know my answer was 93.5 something, but I want to do it this way to make it so like that was what I got, but I'm pretending I got 93.1, and I'm giving you the advice, round up no matter what. So what should I put for the answer on my Pearson right now? Like this is the biggest advice I can give you right here. Like if you got 93.1, round up no matter what. So what should I put in? We'll take a sip of coffee right here. Oh my gosh. Going to the wrong screen. What should I put in? What should be my answer? All the coffee in the world. What should it be? And so if we're going to round up no matter what, our answer would be, remember, rounding up no matter what, it says round up. It's not saying round, it's saying round up. So 93.1, we're pretending. We got 93.1. So that was your answer. I know mine was a little different. And so I'm going to round up no matter what. 94. Make sure to round up. Don't round it. Round up. That's usually where the mistake happens on that one. You got a chance of having where you have to round up like 93.1. Good stuff. Good question. A little tricky one right there. I think we've done... There might be some repeats from the homework. We did nearsighted yesterday, so check out for nearsighted. I think we did philanthropic organization yesterday. Did we do referendum? I think we did referendum yesterday too. And then we did the bank. Might have done them all now. Yeah. So I think the other ones are in yesterday's video. So I think we've done them all. Good stuff. Well, with that, we're going to do some activity here. And then I've got a meeting. So we got enough time. Lillian, stay tuned. Let's do some activity here. Activity coming up. Did you say activity 7 or 8? Lillian, you said activity 7, but I think you mean 8, right? I wrote down 7. You have question 2 from activity 7, but I think it's activity 8 you're wondering about, right? Lillian, correct me if I'm wrong on that, but I think you're wondering about activity 8. Is that accurate? Let me know as I get things ready right here. Or we could do activity 7, but this week's activity 8. So I think you mean activity 8. I think, maybe. I could be wrong. I've been wrong many times in my life. Today could be one of those days. I'm going to get activity 8 pulled up right here, so correct me if I'm wrong on this. Correct me if I'm wrong. We will see right here. Is it activity 8 or 7? We've had no issues with the connects. You're welcome, Cassandra, anytime. Thank you for being here, Cassandra. 100 points. Appreciate it. I'm getting R pulled up. Question 4. Question 2. Interactions. You're welcome, Lily. Is it activity 8? I think it's activity 8. Tell me if I'm wrong. It is all awesome. Thank you, Lillian. Let's do this. Check it out. So we're doing some multiple regression right now. We've got some interactions play a key role. So this week, we're taking our multiple models even further and going to incorporate interactions. Relationships are complex, and the strength of the relationship of Y with one X might depend on another X, not constant. It's always good to explore the possibilities of interactions in the model. Fit a model with all two-way interactions with the twiddle dot square shortcut and name it M interactions. Mint. Not Mint Mobile. Ryan Reynolds, shout out. He's welcome here anytime. Use summary to peruse the long output. Okay. So we've got right here our model, and it's already got the space for the y tilde x. So what y variable are we using? Got to take a look at the launch data set, the product data set. We don't have reg class loaded up, so I'm going to load in all the things above. And we're predicting profit from the 6 other variables. And profit tilde twiddle dot square. There we go. So this is how we get the interaction model right here. The all two-way interactions, and we'll take a look at it here in a second, is going to be twiddle dot square. And what do I mean by twiddle dot? Well, this tilde or twiddle is going to be the separator between the y variable of interest and the x variables over here. So you can think of it as two sides to an equation like y equals. It's going to just set up a formula inside of R so it understands this is the y variable. And then the dot means all our variables, and the square means we're doing the two-way interactions. If you don't do the square, you just get all x variables in your model. And let's take a look. This is not what the question asks. But if you were to just do this, you would have all the x variables. And there's a model with all your x's just by themselves. And if you do to the second power, you get all two-way interactions. And you might have figured it out. If you do to the third power, you get all three-way interactions, and the fourth, and so on. Model starts to get a little bit crazy here. So obviously, you know, make sure you know what you're doing here. Three-way interactions are, though they're interesting. So we want just the two-way interactions. And then we have to understand what this output is showing us, because it's not just about getting this output, it's about knowing what the output means. And what you notice right here is that some of the variables are significant, like the intercept, which no one cares about. That's when all x's are equal to 0. The value of the intercept is likely not 0 because the intercept is statistically significant. Not a big deal. But the x1 is statistically significant, which means the inclusion of x1 in this model brings with it new information. So x1 brings with it new information with the other variables already in the model. So does x2, x4, x5, and that's it. Now, this does not mean the variables by themselves are significant. To do that, we'd have to do a simple regression to see if by themselves they reduce the sums of squared error in a significant way. But in the multiple world, these variables bring with them new information not accounted for by the other variables that reduce the sums of squares in a significant way. Now, there are significant interactions, which means the interactions bring with them new information that would reduce the sums of squares in a significant way in this multiple world. Everything in multiple regression is in the multiple world. It doesn't mean the interaction by itself is significant. And moreover, when we talk about interactions, we need to know how we're talking about them. There is a function we have called C interactions, I believe. Where is it at? C interactions. There it is. And let's see the interactions. Okay. Here we go. Too large? Really? I made so much room for it. So much room for activities. What? Oh, really? No way. Come on. Something's weird. Neighborhood. Oh, it does them all. Maybe I'm thinking, did this code change how it works? Well, that's not going to be good. Is there a different function for it that I forgot? Would the interaction be the thing as when we use the pairs? Not quite. Pairs looks for multicollinearity. Good question, Zillion. 100 points right there. Pairs looks for multicollinearity, where interaction says the way in which x1 explains y depends on x2. I feel like I forgot a... say 10 or something? Yeah, go. Summary of the output. Is there an argument for C interactions that I'm forgetting? There's two of them. Many equals false. Okay. Oh, we want many equals true, I think. Okay. There we go. We're good now. If you don't have the many equals true on, then you will get a whole bunch of plots all at once, apparently. I knew I was forgetting something. So now we are looking at each individual plot right here of the interactions. So it's important to understand what these plots are showing us. And when you see this, we are trying to explain what variable, Lillian, what variable of interest do we care about right here? What variable of interest is the variable of interest? Like the y variable we want to talk about here is what? When you talk about like products, and you talk about a company, the y variable of interest here is what? Like the y variable that we want to understand is what? What is the y variable? Profit. 100 points right there, profit. And it looks like x1 and x3 have a negative association with profit. Now, what you notice right here is it's not just x1 on the x-axis. We've got multiple lines right here where x1 for small, medium, or large values of x3. So this is the interaction with x1 and x3 on how they explain profit. Let's go to a much stronger interaction. I'll show a strong one that'll really help make it clear. Yeah, sure. Tell me, what relationship does x2 have with profit? So what relationship does x2 have with profit? Does it have a positive or negative relationship? Now be careful. This is the idea of an interaction. So does x2 have a positive or negative relationship? Be careful though. It has positive. It has a positive relationship. And 100 points. Thank you for Lillian for practicing right here. Because there's an interaction, x2 has a positive relationship for small values of x4. So when x4 is small, x2 has a positive relationship. But when x4 is large, x2 has a negative relationship. So the way in which x2 explains profit, what's on x4? This is the idea of an interaction. The way in which x2 explains profit, what's on x4? Think of a D word that would go in there. So the way in which x2 explains profit would what on x4? So the way in which x2 explains profit, because sometimes it's a positive relationship, sometimes it's a negative relationship, would what on x4? And that's what an interaction is, to say this one variable. I would say depends. Like the way in which but I would say depends. Like the way in which x2 explains profit depends on the value of x4. For small values of x4, x2 is going to have a positive relationship with profit, and for large values, it's going to have a negative relationship, which means the coefficient of the interaction is going to be negative right here. So if you see this value right here, this has a negative coefficient, because when x4 is larger, it decreases the coefficient of x2. Does that make sense? I'm able to tell the sign of this coefficient right here from looking at this plot. This was actually not statistically significant. The next one apparently is, which is going to be another negative relationship. Let's take a look. Oh, yeah, wow. So what do you notice about these lines that are even more significant right here? This is a really statistically significant interaction right here, Lillian. So what do you notice about the lines? Oh, so it's saying like X4 is like an amount sold or something. So when there's like a small value of X4 for a product, then it would have this relationship. X2 has this relationship. So small values means like if I say a small value of GPA, it would be like someone has like a 1.0 versus a large value of GPA is like a 4.5 or something. So if we say like GPA, when GPA is small, we expect this relationship. Yeah, so it's saying this is a small value. Like when individuals have small values of this. And what do you notice about this super significant interaction? What do you notice about this like ridiculously significant interaction? This interaction is crazy statistically significant. It's actually, there's more like differences between the lines because now the way in which X2 explains profit really depends on X5. For small values of X5, it's going to have a positive relationship, but for larger values of X5, it's going to have a negative relationship. So it looks like the larger X5 is, the more negative the relationship X2 is with profit. So if we want to increase profit right here, smaller X5s would mean X2 has a positive relationship, but when X5 is larger than X2, yeah, that's what you want. You want to be like, okay, so the way in which X2 explains profit depends on X5. X2, like might be good. We might want more X2. We'd want more X2 when X5 is small, that line that goes up. We'd want less X2 when X5 is large because you'd be down here. You'd want to go this way on this line if you want to increase profit. You'd want to go this way. So do we want a large value of X2? Well, that depends on X5. And this is just the kind of reverse relationship. I'll try to find one here. This one I can tell you probably has a very high p-value because take a look. What do you notice about those lines? This is X3 with X4, which maybe is one of the highest p-values. We'll go to the X3, X6. That's the highest. What do you notice about these lines mostly, Lillian, here? These lines are pretty what-ish. Like, you'd say these lines are pretty what, that it'd be like, well, they're kind of about this. I mean, they're not perfect, but they're kind of about that. So what do you notice when interactions are not statistically significant? The lines will be similar. They'll be more, think of what I'm trying to show you here by doing this. Not this, but this. Lines are more, we've got a P word for this that we say lines are more parallel, 100 points right there. So the lines are more parallel because X3 has a negative relationship with profit where X6 has a positive relationship with profit. And it looks like, and Rock knows the answer, it doesn't matter. The value of X3 is really not impacting the relationship X6 has with profit. X6 has a positive relationship with profit irregardless of X3. Where with the other ones, we saw some stronger interactions. There's a pretty strong interaction right here where X6 has a positive relationship for small values, but a negative relationship for large values of X2. So the way in which X6 explains profit probably depends on X2 because is X6 good? Well, it depends on X2. So this is when we're talking about is an interaction statistically significant. It's the way in which one of the variables explains the Y depends on the other one. And you can see these statistically significant interactions right here, like X2 and X5 apparently have one of the strongest, and it'd be this one right here. The more perpendicular lines are generally the more statistically significant. A lot of things come into play there with sample sizes and standard errors, but generally speaking, all else equal, more parallel, less significant, more perpendicular, more significant interaction. Does that help, Lillian, on kind of going through some good key starters for this? It wants the R squared of the model. So we need to go down here. If we want... Oh, I'm doing the plot still. Awesome. Great work, Lillian. Thank you so much. Good practice. If we want things like the R squared, 72.73% of the variation in the Y variable of interest profit is explained by the X is in this multiple model. The R squared adjusted would say that a more fairer assessment, we don't really have an interpretation of it, but kind of penalizing the R squared, a more fairer assessment of the variation explained would be 71.82. to use as a model comparison metric. We don't really have strict interpretations of that one, but that should be used to compare multiple models because it's going to penalize models with more x's, a higher penalty if the x's aren't doing much. It's r squared adjusted for how many x's are in the model. The RMSE is the root mean squared error. That doesn't tell us much till we realize it's the typical miss the model makes. When we are predicting profit, we typically miss our prediction of profit by about 0.2729 if it's thousands of dollars, whatever the units of the problem is. Is that good? Is that bad? I don't know. We got to talk to the shareholders and say, well, we're usually off by our predictions on profit by about 0.2729. That goes to practical significance, and do we actually care, and can we utilize this? How many of the 10 interactions are statistically significant? How many of the 10 interactions? What did I do? How many X's did it want? Is there only 10? Is that 10? I feel like it's more than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What? Did I include extra variable? If you want to see if they're statistically significant, count the stars. I mean, don't count the stars, but count ones with stars. Like, that's statistically significant. I'll double check the quiz. I'll double check it. Like, did I include an extra variable? You think 4? No. Go ahead. 4, 3, 2, 1. And that should be 4 X's. Yeah, the stars are the level. Yeah. Good. Thank you, Lennon, for noticing that. The stars are how significant they are. The dot means it's almost significant. It's got like notes down here on what it means. Dot would be things kind of close to significant. I don't know why it tells you that. Star would be significant between 0.01 to 0.05. Double star is very significant, and triple star is like super duper significant. Like, this is ridiculous significance, ridiculous. But if you just go to where the stars are at, 1, 2, 3, 4, don't count the dot. 5, 6, don't count the dot. 7, 8. Hey, Kayla, great to see you here. What are you up to? How's your day going? We're talking about statistical significance and just showing some additional things. And for some reason, it says it should have 10 interactions, but 10 interactions would be with 4 X's if you permutate them. We have 6 X's. Oh no, it'd be 5 X's. It'd be 5 X's. Running into some issues with scraping Reddit. Oh no, is it stopping you after so many scrapes? Send it to me and I'll take a look, and I'll run it tonight. I've got a big meeting on. Doing well, good. Yeah, what's it? Is it like stopping you? That was because what you might have to do is you might have to put in like a buffer so it starts like doing it, or like every scrape it like pauses and is like, oh, I'm gonna wait a minute here. I sent the info in Discord. Nice, thank you so much. I'll be taking a look. Some things get mad if you start pinging things multiple times. We were doing a thing with Google looking up coordinates, and Google got mad at us because we were hitting it so fast. Like, I was sending like 100 requests to Google in like a second, and Google was like, nope. So I had to build into the scraper. I should go find that scraper again. I had to build into the scraper because this is like a decade ago now. Wow. I had to build in just a pause. So if you run into problems like that, you might just put in that it pauses the scrape and says like, no, we gotta wait like a minute before scraping again, or put in some randomness on it, like a minute plus or minus. But if that's the issue, that would be easy to fix. Maybe it's data set merging, but I'll take a look. So maybe run the loop to go through 5 server at a time. Just every time the loop runs, just put in the inner portion of the loop. How can I add time? Is it a while? I've done counters. So you want to do like a check. We've done it on recently. You want to do like a sys time. Here, I'll talk about that right here. You want to do something with sys time. So sys time will get you the system time, and then you could do like current time. You could store into this the current time, and you would do that at the start of a loop. Does that make sense? Like at the start of the loop, it's going to grab the current time. So whenever it enters into the inner part of the nested loop, the first thing it would do is it would grab current time. So it's going to grab current time, and then at the end of the loop, so we got current time, and then you want to go current time minus sys time. It might be like a while. Whiles connect weird inside of loops. And then you could do an as.integer or as.numeric on this. because we don't want the statement. We just want the numeric value. So you can get the time differential right here on how much time has passed. But that code right there is pretty quick for that, Kayla, to get a time differential on how much time has passed. So at the start of the loop, throwing in a current time or loop start time to then, because if it sounds like that was my concern when we're doing this, is like, is Reddit gonna be mad at us for like grabbing like so many things? Is Reddit gonna be like, you can't be hitting us that many times? And I could go in and try to grab stuff. We get like a partial set of stuff. Yeah, of course. Let me grab this. Hop over here to the Discord. Gotta remember to, I got a person I gotta make sure to talk to. I had their combo up. There we go, Kayla, definitely. Let me take a look at this too. Oh wait, I sent it to the wrong Kayla. I just sent it to other Kayla. All right, there we go. Okay, it happened. Okay, what is it saying? Let me read the error. Cannot read from Reddit. Check your inputs. Okay. It's getting an internal search error. So you know what we want to see if it fails on a certain word. It might have failed on a certain word, Kayla. Like it might not have had any instances of a word for a certain Reddit. So we might want to look at like the error on it. The time buffer might not be the issue. Look at what word it failed, because if your loops are running, find me what word it failed on which Reddit, because there might just be no data for that word on that Reddit. It might be like a smaller Reddit, more of a keyword to religion or stuff. But my guess is also it could have failed on a keyword for a certain Reddit and not created any data set. So when it went to Reddit, it just didn't have any info and it just crashed on that. With that, it failed on our depression the first time, but then worked to a second time. Wonder if and failed on education. Huh. Yeah, we might just need to run it a few times. I mean, it's just going to be like, we got so many scrapes to do, and then we're just going to put all those data sets together. So if you just keep storing what we get, good stuff. With that, I'm going to head off. I got a meeting in 4 minutes. Kayla, I'll see you soon. We'll talk. We're going to get it all scraped and get everything. I'll try the same thing. You got it. Try the time thing. Time thing might help, because it might be like literally saying we're pinging it too much. They get mad when you bot things. Bye for now, everyone. Bye. Yay. See you, Kayla.